Hey everybody, we're back. It's more JavaScript from History 393 Digital History. So we're going to build a little bit in this small lecture on some of the other work we've already done on JavaScript about variables especially. We'll also be using the techniques that we've explored before, conditionals and branching logic and iteration. So let's, though, remember our initial introduction to the concept of variables. And you'll remember that one metaphor that we used was to think of a, a variable as a box into which you put something so that you can take it out later. We also define functions in the same way by creating a variable, a name, that refers to the function, the action that we want to define. And we've already used a lot of functions in our work, but we have not written our own functions. And once you've created a function, you can think of it also as another kind of a box, as a box into which you put something else and take out some transformation of that thing. So you put something into the function, and a little machine runs, and something else comes out the other end. So we have inputs, which we call parameters, and outputs, which we call return values. And we'll write our own functions whenever we need to repeat an action or a process over and over again, an action or a process that changes the state of our variable that does stuff. So in JavaScript, there are two main ways to define functions. They are equivalent to each other, and we will usually use the first form, but it's good to see both of them. And the second one, I think, makes it clearer that a function is really a variable. So in the first method, a little trouble with the selection. There we go. We begin with the keyword function, and then we have the name of the function. So our function is going to be called square, and then we have a set of parentheses. Those are mandatory, and optionally inside the parentheses we have one or more parameters. These are the inputs that we're going to accept with this function. And then after the parentheses we have these curly braces, and inside the curly braces is the stuff that happens, the stuff that gets done when the function is run, when the function is called, as we say. In this case, it's a very simple function. You'll notice that simple line, it begins with the keyword return, and so that what comes after return is the value that is going to be given back when we call the function. So we're going to return, in the case of square, the number times itself. So that's the square of the number. And then we have an almost identical function called cube, which is just being defined in the other way. We can start with let or const cube, and you can just see there's a slight difference in the syntax. Let cube equal function parentheses number, and then the return, what happens inside the curly braces is exactly the same. The keyword return with the value that's going to be returned, in this case, not the square, but the cube of the number to the third power. And if we run these functions, we can see what happens over here, see the results. And I think something useful to notice is that if we change the input to the function, then the output to the function will, in this case, also change. So the important concept there is that the function performs an operation on the input and gives you the result of that operation. In this case, the operation that's being performed is quite simple, but often it will be more complicated and have a bunch of steps. So let's remember our array of historians, given Ramka, Said, Scott. And the very first time we iterated through them, we used a while loop to do that. We can turn this into a function in the following way. So we'll write a function make sentences, which is going to take our array, sum array, and and transform that array into a set of sentences about the entities. So we'll keep the while loop structure, but we're going to add a new variable called output, and we're going to use that to build and store our desired output. So we'll take some array and we'll iterate through the array, and each time we encounter an element of the array, we will add to our initial string, which begins as an empty string. We'll add to it the ith element of historians was a historian, and this is kind of important for your homework. This \n is called an escaped character, and it's a way of writing a carriage return, a line return in your JavaScript code. So far, the main difference is that we are accumulating. We're not logging stuff to the console, but instead we're accumulating, growing a string variable, and then finally we're going to return that string variable as a value. So you can see how this works here. We have two array variables. One is a first set of historians, and the other is a second set of historians. If I run make sentences on the first array, we get these sentences as written here. Edward Gibbon was a historian, Leopold von Ranke was a historian, etc., etc. And now I'll run it on the second set, and we get a new set of sentences. I can also log that value to the console, but we don't really need to do that here because the final entry in the code box here will be printed. Its value will be printed. All right then. So I think maybe you can start to see here how this is being transformed into this. And while it's a tiny bit of extra work to make a function, once the function is made, it allows us to repeat, to do the same thing relatively easily with another set of values. So the key thing about the function is that it will perform the same work on whatever values you give it. Okay. Now, this introduction to functions gives us an opportunity to talk about something that's really important and which will probably trip you up at some point in the course, and that is the concept of variable scope. In JavaScript, variables have values which, as we say, are scoped to a certain part of the code. If the variable is defined as it is here, at the very top of your code, without being inside any curly braces, then the scope of that variable is what we call global. It applies throughout your code, but you can override these global variables in smaller scopes. In particular, one place where we often do this is in functions. So here I have a global variable a, and at the global scope, its value is set to just some string. Inside the function scope example, I'm going to set a again to another value, and I'm going to use it in the return value. So if we check out A, the value of A is just some string. If we print scope example, we'll see that even though A is in the global scope is just some string, we see that A actually equals, I set this value inside the function as long as we're inside the scope of the function. And something else to note is that inside the scope example, we have a value called any string, a variable called any string. If I try to access it from the global scope, it'll tell me it's undefined. If instead I try to access it from here, so one thing to notice here is that the the named parameter in the function definition defines and assigns a value to a variable which can only be accessed within the scope of the function. So I can write code that refers to any string inside the function, and it will work fine. If I try to access any string from outside the function, it will give me a reference error. And just to note here, so here we're passing a value directly. It's a string, and that is given the name any string as long as we're inside the function. This stuff may sound a little confusing at first, and it is actually quite complex theoretically, but if you practically, it becomes second nature very quickly to think about how variables are defined in different scopes. Maybe a thing to do would be to play around with this code in your version of this lecture. Just a little bit more advanced discussion about scope. Scope doesn't just take place, it doesn't just, in JavaScript, with let statements, and with let bound variables in particular, a new scope is defined every time we enter a set of curly braces. So it's not just in functions, but we can also do it in a so-called block, a for or while block or an if block, and so forth. And the scope scales in this way. The broadest is global, and then usually function, and then a block, and then a block that's nested inside the block, and so forth. Yeah. And you can see here, you can play around with this a little bit yourself. How the value of A changes as you move from scope to scope. Okay. In the assignment, there are lots of ways to go wrong. And one big problem that people have in the initial stage of the assignment is to is a problem remembering that you have to return the value. So you might do all the work of creating the value that the function needs to create and then forget to return that value. Your tests are going to compare the return value of the function to some expected value. So in order to pass the test, and in order for your functions to be useful in bigger pieces of code, you are going to have to be sure to give a return value with the keyword return. And a hint that I may not work with the new changes in Quokka, I'll wait for you guys to confirm this, that one way to really have some help with debugging your code is to just check the value of your variables from time to time. And you can do this if Quokka is working for you in VS Code by just typing the name of a variable by itself on a line, and Quokka will show the value of that variable right next to the variable itself in the code. Okay. And then I want to give you a couple more hints based on problems that people have had in the past. Just moments ago, I told you that a function is a variable. That is true, and it's really important to know that as you move forward. But it might be easier to think of a function less as a variable like other variables and more as a kind of robot. So let's define a new function called robot cleaner, right? And let's take a quick look at robot cleaner. All it does, so it has no parameters. So it does one thing about a function with no parameters, it does the same thing every single time. In this case, it defines string output, I cleaned your room, and it returns the output. So I'm going to define a new variable r and set it equal to the output of robot cleaner. And then we'll just see the value of r. The value of r is going to be I cleaned your room, because the return value of robot cleaner is I cleaned your room. So when you write a function, you build a function to do something. You name it whatever you want to. The return value is what the function gives you back. You need to call the return value whenever you need this thing done. Okay, so let's say you built this robot cleaner because your room is a mess. I mean, that's why I would build a robot cleaner, because my room is disgusting. And I would, call it maybe, if it's a robot cleaner, maybe I'll call it every day, try and clean up my room, certainly like a couple times a week. Now, a really important thing to recognize is that the name and the return value are not the same thing. And this is confusing to people when they start. So we can have this function, robot cleaner. Its form is still the same. It's defined in the same way, but look what's happened. The output has been changed from I cleaned your room to haha, I have replaced your robot cleaner. Now your room is even messier. And that's because the robot cleaner has been replaced by like a Soviet spy team in a Cold War movie from the spy movie from like the 1980s. So when you do the assignment, it's important always to modify the existing function. Don't get confused and try to somehow modify the function call. Suppose you want to make the robot messier, the robot mess up the room, and you decide to rename the function robot messer upper. That's not going to do anything because there is no intrinsic relationship between the name and the return value. Although in this case it's a little bit weird because of the cache value, but yeah, so there's no intrinsic relationship between the name and the return value. Just having named something the right name is not going to fix the problem for you. Okay, And then I want to talk a little bit about the relationship between parameters and output and how to fail the assignment. And so this is like a key method for failing the assignment that has been used by generations of students taking this class. When you write a function, in general, always in the case of our assignments, the return value of the function should make use of the parameter that is passed to the function. So, suppose you've been asked to write a function that that when passed Margaret Atwood as a parameter, outputs Margaret Atwood was a great writer. And if we look at this, we can see that, in fact, the function great writer does just what we expect when we pass it Margaret Atwood. It passes the output. It returns the string Margaret Atwood was a great writer. Awesome. You might think, now I've done the work that I had to do. I'll move on to the next assignment, or the next problem in the assignment. But if we pass that same function great writer the string Toni Morrison, it does not give us the expected output anymore. Now it still gives us the string Margaret Atwood was a great writer instead of Toni Morrison was a great writer. And that's because the output has been statically defined here. And instead, we want to construct the output using the input in some way. In this case, what we're doing is taking the parameter name and generating the output string by adding or by concatenating the name and the string was a great writer. And we can see it works for Margaret Atwood still, and it also works for Toni Morrison. So you might want to stop, take a look at this, and make sure you understand it, because this is one of the things that gets about 10 to 40% of the students who are trying to do the JavaScript assignment for the first time. Okay, let's talk about this, about parts of things. Okay, so we've talked a lot about functions. I think you should understand it pretty well. I want you to note this syntax for referring to parts of larger things in JavaScript. So in this case, we have defined an array, and you're already familiar with arrays. So A has 3 elements: name, 0, and other info. And if I try to log to the console the 2th element of A, we find that it's other info. And you'll remember that that's because arrays in JavaScript are 0 index. So the first element gets the index of 0. The second element gets the index of 1, and it's only the third element that has the index of 2. So that square bracket on an array and on other things called objects, which we'll talk about later, is a way of telling JavaScript, I would like to retrieve a part of this bigger variable, this value, the value of A. So I'm going to return, I want to retrieve the third element in the array A. And then we've also seen this. A.length oh dear. So A.length is a way of accessing a a property of A. So A is an array, and by virtue simply of being an array, it has a whole bunch of properties, and one of the properties is that it has a length, and we access that length, the length property of the array, by writing the name of the variable A, and then a dot, a period, followed by the name of the property. And so it's important to recognize that in addition to the kind of um, uh, visible elements, there are lots of invisible properties associated with many JavaScript variables. So bear that in mind, and you'll read about that more in the MDN and Mozilla Developers Network. Notice that if we write it this way, it doesn't give us the length, but instead it gives us the 0th element of A because length is not defined. And then I want to show you that there's a special property. We've used this already, a.pop. It's a property of A that is defined because A is an array, but it's a special kind of property. It's a property which is also a function, and so I can either just show you, ask JavaScript to display the value of that property, and it says that that property is defined as a function, or I can actually execute that function by typing a set of brackets after the name, and then it will perform the task that's being asked of it, namely to pop something off the end of the array. Similarly, a.push is a function. And if I run a.push, then it will change the value of the array in another way. I'm just noting here that these are not the same thing. A.pop and a.pop parentheses mean really different things to JavaScript. Okay, those are some things about functions and some slightly random notes about how to proceed on the problem set. And we will tune in again with another short video soon.